All right, today we're going to talk about sequences. Sequences with addition, arithmetic sequences. So we're going to recognize whether or not they are arithmetic sequences, and then we're also going to do some formulas with them. So let's talk about what a sequence is. A sequence is a pattern that increases or decreases at a constant rate. That rate, or that value, whatever you want to call it, is called the common difference. And that's going to need to be known. We will signify that with a letter D. D stands for the common difference. All right, so let's take a look at a couple and see if they are in a pattern or not, if we can tell. So the first part is going to be just, can we tell if they're in a sequence? So negative 15 to negative 13 to negative 11 to negative 9. So we're going to go ahead and how do we get from negative 15 to negative 13? Well, we add 2, and then we add 2 again, and then we add 2. Because this is the same going all the way across, this is a sequence. The next one would be negative 7, then negative 5, and so on and so forth. And we can do that by just adding 2. And this has to be common. This has to be the same going across. And that's what our common difference is. It's 2. All right, what about this one? Fractions, I know you don't like fractions, but we notice there's 8s in the denominator. So let's look at the next one. 7 to 5, that's minus 2. And then 5 to 1 is minus 4. And then 1 to negative 5 is minus 6. So minus 2, then 4, then 6. That's a pattern, but it's not an arithmetic sequence. It's not an arithmetic pattern. So this is a no, because it changes. 1/4, then 1/2, then 3/4. That's not the same. How can we figure these out if you don't like to just do it? You just subtract them. 5/8 minus 7/8 in your calculator, and that'll get you the number. And so you just subtract these, subtract them, and find out what the difference is. And it changes. And since it changes, this is not an arithmetic sequence. All right, what about this one? Be careful. 2, 4, 6, 8, 10, 12. That looks like it's good, except for notice again that 6 is missing in the middle. So it's 2, then it's 4, and once there's a difference, we know it's not. All right, 2/3 to 1 to 4/3 to 5/3 to 2. Be careful with this. Remember, 1 is 3 over 3. We can write it as 3/3. So it goes from 2 to 3 to 4 to 5. And what about 2? 2 is 6/3. So all of those, it goes in order. So this is good. All right, some terminology when you're doing this. For a sequence, you should be able to add the common difference each time and get to the next one. So this symbology here, a sub 1 is what this is called. It's considered the first term. A sub 2 would be the second term. A sub 3 would be the third term. A sub 4 would be the fourth term. A sub 25 is the 25th term. So that's just what it means. What's the first number? That's A1. Second number is A2, so on and so forth. And how do we get to the next one? You just add D. All right, so let's look at this. So we have a sequence here. They tell us it's a sequence. It goes from negative 8 to negative 11. So how do we get from negative 8 to negative 11? We subtract 3, and then subtract 3, then subtract 3. So how do we find the next 3 terms? Since those are all subtract 3, we're going to just continue to subtract 3 to get the next one. And so the next one is negative 20, and the next one is negative 23, and then negative 26. This is called a recursive formula because we go ahead and it just keeps recurring over and over again. We just keep doing the same thing, boom, boom, boom. So the next terms are there. What about this one? 58 to 63 to 68 to 73. That's going up 5. So from 73, we need to go to 78, then 83, then 88. So this one's most assuredly A. Now, sometimes we don't want the next 3 terms in a row. Sometimes we want to know what's the 17th term or what's the 25th term. And so we need a different formula for that. And here's the formula. It's the first term plus whatever term we're trying to find, let's say the 25th term, 25 minus 1, times the difference, the D. All right. This will go ahead and give us a specific value, again, 17th term or 21st term. Could we go ahead the other way and just keep adding them up and figuring out? Yeah, but that could take a while. What if I want the 100th term? This makes it a lot easier to go ahead and do that. So here we have one going from 1 to 10 to 19 to 28. So the difference is 9, and they want us to write an equation. So to do this, we got to find the difference, which is 9, as I just said. And then we use the formula. So the first term was 1, so we're going to put a 1 there. N minus 1 is what it is, and the difference is 9. We're going to distribute this, and 9 minus 9. And then we take that minus 9 and add it to the 1, and we get minus 8. And that's our formula. And how does that help us? Well, if I want to find the 12th term, I can just put 12 in for that next to that 9. 9 times 12 minus 8, or 100. So the 12th term in this series is 100. Now, could we have added up to get there? Yeah, but we don't really want to. We want to be able to jump straight to the term that we want. And 12 wouldn't have been too bad, but again, what about the 51st term or the 101st term? All right, here's another one. 2 to 7 to 12, we're adding 5. So how do we find the 12th term? We start with the first term, which is 2. The difference is 5, and 12 minus 1. Well, 12 minus 1 is 11. 11 times 5 is 55. Add that first term for 57. So the 12th term would be 57. It's not that hard to go ahead and do. All right, what if they just leave it like this? They don't give us the whole sequence. Well, that's fine. We can interpret this. A1, remember, is the first term. That's what we need here. The difference is 4, and n is 7 minus 1. So 7 minus 1, make sure that you always minus that 1, please. It gets 6. 6 times 4 is 24. 24 plus the original term, the negative 2, is 22. And we can even write an equation, like we said before. So the first term is 19. The difference is minus 2. We're subtracting 2 each time. N minus 1. So distribute. 2n, negative 2 times negative 1 is positive 2. So again, we just add the first and the last for 21. And then minus 2n. If you want to write plus a negative 2n, that would have been fine too. And that's what I have for you today.